Hello there, and welcome to Explained in VR. Today we are going to look at how a CPU works. Now, a lot of people out there don't really know what goes on underneath that lid on your CPU. It's a silver block, and it just does all the maths for you. So today we are going to look at what's underneath that little silver chip and see how it works. The central processing unit is pretty complex, so we are going to simplify a few things here. But the general principles haven't really changed. Starting big, that's just the fan and the heatsink, not actually part of the CPU at all, just thermal dynamics trying to keep it cool. Underneath that, we have the IHS, which is the integrated heat spreader. This is just a slice of nickel-plated copper to spread the heat from the die beneath. It also acts as a little bit of protection for the silicon that the die is made of, because that's very fragile. As you can see, the die is actually much smaller than the IHS would suggest. These can come in various shapes, sizes, configurations, and are printed from sheets of silicon and cut out for each chip, basically. You can now see the die is split up into the constituent parts of the processor. This is just a rough idea of where the big sections are for reference. These things can move around and be in any place, but this is just to give you an idea of scale as well. The pins and pads on the other side of the chip are where all the inputs come in, of course, and then these inputs are stored in the cache memory before it is used by the processing unit itself. And so now is a good time to explain the difference between cache and RAM. Cache is on-chip memory. It's very fast, but it's also very expensive to make. Hence, you get very small capacities on the chip. But the ideal place for the next few calculations to be stored is right next to the CPU. So L1 or layer 1 is really, really small, but really, really fast. L2 is a little bit bigger, a little bit cheaper, but also, again, a little bit slower. And L3, as you can see, is the biggest cache, but also the slowest. This is also generally shared between however many cores you have. Once the processing unit is ready for the data, it is called up by the control unit. This is the part which tells the other parts what to do and doesn't actually do any program's execution itself. It rather just tells other parts what to do. The actual program execution is performed by the arithmetic or logic unit. This is where we start talking about logic gates and even transistors themselves. This section can perform 4 types of arithmetic. It can do adding, multiplying, subtracting, and dividing. Or for logical tasks, it's a little bit more complex, but basically it generally compares 2 sets of data. Do these things match? Is this number bigger than this number? Is this number smaller than this number? Etc., etc. What I've got here is a simple 2-bit addition adder drawn out for you. Check out some of the info on logic gates if you don't really follow this, but arrange a handful of transistors and you'll get each of the logic gates. Arrange the gates as you see here and you'll get some simple adding. Arrange lots of adders and you can multiply or divide as it may be, because 6 times 7 is just 6 add 6. 6 more times. The more you chain together, the more you can do. Once this is done, the result is then sent to be stored in the cache if needed soon, if the RAM if not needed right away, or back to the hard drive if it is completely done with it. Thanks for checking out this episode of Explained in VR, and do remember to like and subscribe if you enjoyed the video, or dislike if you really hate it. And also share this with anyone you think it might help. If you do have any ideas for the next episode, do drop something in the comments below, as I'm sure to read them, and I'll have a go at making it for the next video. Again, thanks for watching, and see you next time.